Hi guys, so this is going to be the second section video for chapter 10. This is going to um, address learning objectives number 2, 3, 4, and 5. So we're going to cover a lot in this section. So that those learning objectives include defining and explaining and examples of non-equivalent group designs, explaining how individual differences are a threat to the internal validity of those non-equivalent group designs, and then describing and identifying two non-experimental, non-equivalent group designs, and then um, how that simple modification of a post-test only non-equivalent group control group increases the internal validity and results in a quasi-experimental um, design, which a lot of that is probably, if you haven't read the chapter yet, you're like, what? But that's okay. It's a lot of words. We're going to walk through it. Hopefully, though, you have actually looked at the textbook before watching these PowerPoint videos because I feel like you will be able to get more from these if you actually read the chapter first and then use this as kind of a guide, or even read the chapter, read a section, and then watch this video, and then read a section and watch this video, um, because I want to make sure that you guys have something to kind of guide you and help it make more sense. But I feel like it would make more sense if you've already read some of the content. So in chapter 8, we talked about between subjects experimental design, remember, and we talked about controlling individual differences, because remember, individual differences is the issue with between subjects design, the threat to internal validity there. And so we talked about controlling that by randomly assigning your participants to the groups, or by matching the participants across conditions or across groups to try to reduce those individual differences. But remember, with the non-experimental design, we are not manipulating the groups. The groups are pre-existing. And so what happens if the groups are pre-existing? How can we control these individual differences, or can we? So that's what we're going to talk about. So the non-equivalent group design is when the different groups of participants are formed under circumstances that don't allow the researcher to control that assignment, right? So we can't say you're going in this condition of this group and you're going in this condition of this group. The groups already exist. They cannot, so like I said, they cannot use random assignment to create these groups of participants because they come in already having this, this variable. They're already defined on that variable. So the example your book uses is high schools with that encourage the use of technology during learning, and then the high schools that don't encourage it or that ban the technology during learning, and they want to compare the performance of those high schools, of those students, on or to see if there's a difference between using technology and not. And so obviously those groups already exist. Either the high school has a policy against it or for it, and that's it. Like there's nothing that you can do about that. So, oh, I hit the wrong thing again. Sorry, guys. All right. So obviously that means there are some threats to internal validity, right? Because the groups are differentiated by a variable or a factor that is identifying the groups, like high school that uses technology, high school that doesn't. And we cannot do anything about the individual differences, um, between them. We're not controlling any of that. Um, so, before quick, I'm going to go to this and I will come back. But so this is the general structure of a non-equivalent group study. So again, we're looking for a difference between the groups. You see that at the bottom. Those are the scores that are obtained for the individuals in each group. And there's two groups here, two conditions, based on whatever variable we're studying. In our example, we're talking about technology, the high school policy, whether there's technology or not. Um, So the individual differences here, we can't do a clear cause and effect explanation because there's so many other individual differences that have to be taken into consideration, that could have an effect. So the groups have different participant characteristics, right? There's things like, and there's things that could affect the dependent variable or that affect the other variable we're studying, which is performance, right? There's IQ. All of the students have, the different high schools have different IQ. There's socioeconomic status. There's racial mix. There's, single parent or, two-parent homes. There's the student motivation. There's the teaching staff and the type of teaching they're receiving. We could go on and on, right? There's so many different things that could affect the student's performance in each of the high schools. And so, um, there's no way to control those, right? Because the groups already exist, and we can't randomly assign to groups, right? There's no assurance of equivalent groups. We can't determine if those high schools are similar or not, which we'll get to that in a second. We could actually, if we made an extra step, but in this case, with this design, we don't know. And so if there could be other variables, there could be other factors, right, that are affecting performance. So that's why we can't say a clear cause and effect explanation here. So there are three common examples of non-equivalent group designs. And and again, back to this. This is why we call it non-equivalent group design, is because the groups are not equivalent. We have no way of assuring through random assignment or any other way that they are similar beforehand, that they are equivalent beforehand. So, or equivalent on all other factors, right? So there's three different examples of this. There's a differential research design, there's a post-test only non-equivalent control group design, and a pre-test post-test non-equivalent control group design. A lot of words, I know. It'll make more sense when we go through it here in a second. Let me go back to this. These first two, 1 and 2, make no attempt to control or minimize individual differences. There's no modifications made. And because of that, they are considered non-experimental designs. This third design down here, the pretest post-test, they actually are making a modification by introducing a pretest that tries to reduce some of these individual differences and these issues that we talked about. And so that is actually considered a quasi-experimental because that extra step is taken. So we'll detail that more in a minute. So we already looked at that. Okay, so the first example we talked about of the three is differential research design. And so this is just at the basic root, a research study that compares pre-existing groups. Again, the goal is to establish differences between these pre-existing groups. It's also called an ex post facto design because that means after the fact. And it's because it's looking for differences between groups after the fact, meaning after they've already been in a group, right? They existed, they already exist in that group beforehand. And so that's why it's called differential research design, because they're looking for differences between these groups, right? So some examples from your book and elsewhere, you could look at the difference in, or what some, this is actual examples of research that's been done. They looked at car accidents. That's the dependent variable. I'm using air quotes. You can't see me around dependent variable, by astrological sign. So the, Leo, Gemini, Capricorn, all of those. They looked at, those are obviously pre-existing groups, right? They didn't assign them to an astrological sign. They what they are, depending on when they were born. And so they compared those groups, those pre-existing groups, on their car accidents to see if there really is a difference between them on the number of accidents that they have in vehicles. Or there was another research where they swung a pendulum towards the participants, and they tested their reaction time, and they wanted to compare ages and genders. And again, age and gender are pre-existing groups, right? You can't change how old someone is, and they come into the study with whatever gender they are, and so you're not manipulating that. So that is a non-equivalent um, design, and it is or non-equivalent group design, and that is an example of differential research. Just looking for differences between pre-existing groups. Your book points out that a lot of social psychology and personality psychology research is done with this kind of design, with this differential research design, because um, it is most of the theories and things in social psych and personality are pre-existing, right? Like personality types or things like that. Attachment styles was an example they used in the book as well. Those are pre-existing groups, and so they can compare different attachment styles or different personality characteristics on any kind of different variables. Do they have more relationships, romantic relationships? Do their interpersonal relationships last longer? Depending on what personality trait you have or what attachment style you have, right? And so those are more examples of differential research. Now let's go to this box 10.1 because it talks about the comparison here. You guys might be thinking, all of the examples I just gave sounded a lot like correlational research, and you wouldn't be wrong if you thought that. If you didn't think that, it's totally okay if that didn't occur to you until now. But they are similar. They are looking at two different variables. They're looking for a relationship between two different variables. All of that is true. But as you can see in this figure 10.4, part A up at the top is a differential study, a differential research design. B at the bottom is an example of correlational study. So you can see visually, obviously, there's a difference, right, between the data here, or the way it's structured. But I'll tell you what the actual difference is here. With differential, remember, we are comparing two different groups. So that first variable, which in this example is self-esteem, we are splitting the participants into high self-esteem and low self-esteem. So we're using that first variable to define our groups. So we have two different groups, and we're comparing those two different groups, the averages or the mean or whatever it is. We're comparing the two groups to see if there is a significant difference between high self-esteem and low self-esteem in terms of academic performance. That's what the scores are. That's what the second variable is academic performance. Okay, so that is the way that a differential study is structured, right? We've been talking a lot about that kind of structure and things, so that should seem familiar. Correlational research, which again we introduced in chapter 6, but I know you don't necessarily know a lot about that. We'll talk more about it in chapter 12. But you can see down here, the same variables are being studied here. They're still looking at self-esteem and academic performance. But correlational studies, instead of using that first variable, that self-esteem variable, to define groups, they are measuring that first variable and treating, not that they didn't measure it in the first one, but they're measuring it and treating it just like the second variable as far as just listing all the participants in one group. There is not multiple groups here. There's just one group. You see there's participants, A, B, C, D, all the participants. And then we're just looking at the two variables, just their scores, the individual scores for each participant on both variables. And instead of comparing groups here, what they're doing is they're seeing if the two variables, if the numbers in the two variables move together. In other words, do they increase together or decrease together, or as one increases, does one decrease, or vice versa? And so they're seeing how the variables move together. So they both types of research are giving you information on the relationship between self-esteem and academic performance, and they should find similar results. No matter which type of design you use, you should find that, the example here, that higher self-esteem leads to higher academic performance. you should see that in both um, studies. But the difference is with the differential study, you would be able to say the high self-esteem group had significantly higher academic performance than the low self-esteem group, which leads us to believe that if there is higher, if a student has higher self-esteem, they are likely to have higher academic performance. In B, for correlational study, you would say that the correlation revealed that as self-esteem increased, academic performance also increased. And so we would assume that that would be true for any other individuals if, as you maybe implement a program to raise self-esteem, that their academic performance could increase as well. It could also be the other way around, right? For a correlational study, you could say that as their academic performance goes up, their self-esteem goes up, right? But from just a correlational study, you don't really know if one caused the other, or which one caused, which one is affecting the other, or if they're just affecting each other. With a differential study here, you can see that that by separating them into groups, it leads you to believe that the self-esteem is what is influencing to a certain extent the academic performance. But again, you could technically divide the groups on academic performance and see if and look at their self-esteem scores and see if it was the other way around true as well. But again, it should the results should match up. It's just two different ways of looking at and structuring your research, right? So I hope that clarifies that for you guys. So that was all differential, okay? Now, the second type of non-equivalent group design is a post-test only non-equivalent group design, okay? So again, we're still using pre-existing groups here because it's non-experimental, but instead of looking at comparing a variable on pre-existing groups, a post-test only is the idea of, this is more in the clinical research where we're looking at a treatment condition. And so this would be a situation where one group received the treatment and one group did not. Again, this is pre-existing. We didn't determine this. This had already happened when we came into the study, or when we decided to pull our data. They already had, some groups had received treatment and some had not, and so you can compare them to see if this treatment or therapy or clinical intervention or whatever it is effective. Again, there's no random assignment here, but the second group of participants that had not received the treatment is considered our control group. But again, it is a non-equivalent control group because it was pre-existing. We did not randomly assign. So again, it's called a non-equivalent control group. The example that your book uses is, or there's two different ones, parks versus no parks. So a neighborhood where a park was created and then a neighborhood where there was not a park created, and they compared social interactions. So they improve social interactions with their neighbors by building a park. And then the other example is an ethics course to evaluate the effectiveness of an ethics course. Again, you would compare students who had received the ethics course, had gone through that training, and those who had not, and see if there's a difference. So again, you're comparing pre-existing groups. It sounds, again, a lot like differential, like what we just talked about. The difference is this control group. There's a group that does not experience the treatment, the intervention, the therapy, whatever it is. And so that's the difference here between the differential and the post-test only. The reason it's called post-test is, again, to give you a visual example. Let me see, I can't remember. I think it's on the next page. Yes. This chart gives you an example. Oh, wait, no, that's the pre-test. Whoa, we went too far. There it is. The X is showing you the treatment or the intervention or the therapy or the ethics course or whatever. The O is showing you when you observe the participants. So post-test meaning after the treatment. So they have some kind of treatment, and then you observe and you write down the measurements, right? And so both groups are measured at the same time. You can see the O is the same. They're measured at the same time, and it's after the treatment. It's just that the non-equivalent control group, see, there's no X. They did not receive the treatment. They're just observed at the same time or measured at the same time as the treatment group after the treatment group has experienced their oh, and also this says here at the bottom that if there is an R, an uppercase R symbol in here, then that would mean that that would symbolize that they were randomly assigned. And so that would let you know that it's an actual experimental design. If there's no R, like here, there's no R, that means they were not randomly assigned. So it was a pre-existing treatment group. And again, that non-equivalent control group also tells you that it is not an experiment, that it is non-experimental. Okay, so I kind of showed you this a second ago. I gave you a preview of what was coming. So the problem with the non-equivalent control group, the post-test only, we talked about this a minute ago, that you have no way of knowing if the groups are similar beforehand, right? And so what if they're already different on a lot of things that could affect the dependent variable before you even do the treatment? That's going to affect your observational scores in the post-test, right? But you're not going to know what's causing that or why they're different. And so you can modify, and this is where we're going into a quasi-experimental design, is because they're adding a pretest beforehand. So that was this picture that I showed you a second ago, right here. So you can see there's a pretest where they're observed or measured before. Then there's a treatment for one of the groups, and then both groups are measured or observed again for a post-test. So there's a pre-test, treatment, post-test, and then we can compare, just the way we did before. We can compare the groups on the post-test, but because we can compare them on the pre-test, we can know whether or not they were actually similar or different beforehand, before the treatment ever was introduced. So this shows you, this just kind of walks you through it. One group is measured twice, once before the treatment and then after, and then the second group is measured twice as well at the same time, but there's just not a treatment in between. That's your non-equivalent control group. This design is attempting to limit the threat to internal validity. That's why it's called quasi-experimental. They're trying to do that by, again, comparing the pretest, comparing the groups on the pretest to see if they're similar on whatever variable you're studying. Again, like those high schools, you could measure their performance ahead of time and make sure that they are similar in performance before you, or well, no, that example wouldn't really, I'm sorry, that example wouldn't work because the policy is already in place. Let's pretend the policy wasn't in place yet for technology. You could test them before the policy was in place, and then one high school implements the policy to use technology, and then you could test them after. And again, if their pre-test scores were similar, then you would feel confident that if their post-test scores were different between the two groups, then it had something to do with the policy. Similar with the parks, if you knew the parks were going to be built in a certain neighborhood, you could pre-test their social interactions before the parks were built. Compare them, make sure their social interactions are similar between the neighborhoods before, then build the park then the park is built in one of the neighborhoods. You're not doing the building. This is pre-existing, right? The park's built. And then you compare them again and see if their social interactions have changed. And that would help you see and help you be more confident that those individual differences are reduced because you saw that they were similar before in the pretest. But this is only measuring the pretest is only measuring one variable, the variable that you're interested in, right? It's not addressing all the other potential variables that could influence their scores on the post-test. So it is limiting or reducing the individual differences, but it is not eliminating them altogether. So it's only quasi-experimental because there's still a lot of confounds that you're not accounting for. Again, with this chart here, so let's say at the end, in the post-test, the treatment group and the non-equivalent group were the same. Their scores were the same. You would think, on the post-test, you would think, oh, well, the treatment didn't have an effect. But with the pre-test, if you look at the pre-test and they were different when they started, then it's likely that there was a time-related factor or a threat, like a history effect or something like that. And if that's the case, then there's going to be what they call differential effects, like history. So where it makes it, so that identifies that there's a possible effect, right? Now, if there was a difference at the beginning in the pretest and also a difference at the end of the post-test, then it could have been the treatment that caused the difference in the post-test. But since they were different in the pretest, that suggests that there, again, could be some differential effects, some history effects, some maturation, whatever, instrumentation. There could be an issue there because it could make it look like there's a difference from the treatment, but there really wasn't. And so that pretest can help determine possible threats to internal validity and issues with your design. Here is some things to just think about. You can screenshot this, think through these things. Again, trying to kind of get you thinking about potential issues with individual differences and how that can affect validity and bias in these experimental designs. And then if we go to here we have the learning check. For which of the following studies does the researcher not control which individuals are assigned to which group? So if they're not controlling, hopefully you know that that's non-equivalent group design. A between subjects experiment and a within subject experiment, remember those are experiments, so they are going to be assigned. They are going to be controlled. And then pre-post design isn't even something we've talked about. So there you go. And then which of the following is the primary threat to internal validity for non-equivalent group designs? So again, for the non-equivalent group designs, that's like a between subjects design for an experiment. So always the primary threat is going to be those individual differences between the treatment groups, always. Those history effects, instrumentation effects, regression towards the mean, those are things that are more for like a within subjects comparison or a pre-post test design where the same participants are being measured more than once. And then which research design is used by a researcher comparing self-esteem scores for children from divorced families versus scores for children from families with no divorce. So again, pre-existing groups, either divorced families or not, they're comparing self-esteem. So they're just looking for differences between pre-existing groups. And so you should know that's differential. Remember, we're looking for differences from pre-existing groups. The pre-test and post-test, and even time series, which we haven't even talked about yet, but those are things that are going to be happening before and after or after a treatment. That's a more clinical type of thing, or there's some kind of pre-test or post-test when they're just simply looking for differences between groups on self-esteem. It's differential. Which of the following is the primary advantage of a pre-test post-test non-equivalent group design in comparison to other non-equivalent group designs? So I kind of just talked about this a second ago, but pre-test, post-test, so remember we're adding the pre-test component. What does that do? Hopefully you know that is reducing the threat of individual differences. So remember that the history effects here, that isn't a concern of the other non-equivalent groups, because again, those are like the between subjects designs. And also, post-test scores aren't really reducing or eliminating history effects anyway. That would be the pre-test would help demonstrate or help us with that. So that doesn't even make any sense. And then the last two answers, the pre-test scores, the difference is the reducing or eliminating. And hopefully you remember that you cannot truly eliminate the individual differences between the groups because it's quasi-experimental. There's not true manipulation, not true control, so we cannot eliminate those individual differences entirely. We can just reduce them with that pre-test component. So that's 10.2, and I am here if you guys have any questions about this section.